Welcome to VMware vDefend Security for VCF 5.x. This is the troubleshooting module. My name is Chris McCain. I am a director at VMware by Broadcom, and I work specifically in the application networking and security division. Let's start off talking about log correlation and security incident and event management. So log correlation and SIEM, as you may have heard the term, logs are about capturing state change information. Example, TCP SYN from the network connection or a user login. Events are defined as actions based on several logs or the trends of logs. For example, might be an ICMP packet flood, user access locked because of 5 unsuccessful logins. The configuration of all systems to create logs, logging activation, and store definition. Log correlation in SIEM is really about building a centralized log analysis system. Now, syslog, which originated by BSD and defined by RFC 3164, has logs usually contain the process ID, a timestamp, and the host name or IP address of the device. So identification of facility and severity, the facility being 0 to 23, identifying a system daemon, and the severity of 0 through 7, where 0 is the most critical. Some issues with log generation. Oftentimes there's multiple log sources. So a single system can have multiple log sources. For example, the operating system, the application itself, or a component of an application, the login of the user. Logs can sometimes be inconsistent, or the content in the logs can be inconsistent. So what is logged might be dependent on options chosen by a server admin. So if you're thinking in terms of log consolidation, logs coming from different sources, the information, the level of detail can be inconsistent because of an end user configuration of what data is being logged. Inconsistent timestamps make it difficult to analyze if log events are not NTP time synced. Millisecond precision is often required. Time zone can also present a challenge. So you have to think in the context of pulling together logs to identify what might have happened over a certain period of time. We need to ensure that the times across all of the different log sources or data sources are synced in a way that allow them to come together and tell a story as one unit. And then finally, inconsistent log format. So date by the systems or territories, US, EU time format, date format, etc. So a handful of challenges that we have to deal with when it comes to log correlation and SIEMs. So what exactly do we mean by a SIEM? Well, security information management, SIM, is log management, compliance reporting, the collection and storage of log data generated by different devices or software, applications, operating systems, etc. The normalization and analysis of data to identify potential security incidents or violations to policy or compliance requirements, or even the identification of anomalies. A security information management system facilitates compliance by generating reports and creating audit trails that we can follow to get a better understanding of what is configured or how things are performing in the environment. Now, security event management is real-time monitoring and analysis of security events, as well as the correlation of data from various sources to identify patterns or trends, especially when it comes to potential threats. We are talking about security. So in the realm of cybersecurity, the ability to correlate the patterns and trends into identifiable threats is a very powerful way to have an understanding of something that might be happening in the environment. So security event and information management, put them all together, combines the SIM and the SEM functions. This provides a comprehensive view of an organization's security posture by collecting and centralizing this data. This helps organizations gather, analyze, and correlate security-related information from a variety of sources, including, but not limited to, IDS, IPS, antivirus, servers, firewalls, and more. The SIEM, Security Event and Information Management, can send alerts to analysts, allowing them to investigate threats early on. Common SIEMs, Splunk, ArcSight, IBM QRadar, just to name a few. Log management is an integral part of a SIEM because log entries are a wonderful source of information. Though highly crucial, solely collecting and aggregating logs at a central location is not enough. So it's not just about collecting the data. We have to understand it and we have to be able to act on it. So we have to have information. We have to have a correlation of all of this information to be able to determine if the data we're collecting is representative of something going on in the environment that we might need to know about. And if we need to know about it, then we need alerts. We need alerting of these abnormal actions in order for us to be able to understand a potential threat and perform threat management. So we have to take all of this, the log files, the log entries, the correlation, the alerts, and that's what tells us if there's an incident going on. So most alerts require manual analysis by a SOC analyst. The experience gained from handling incidents or false positives can serve as input for a new use case or for fine-tuning. Okay, let's turn our attention and talk a little bit about data plane operations and how we can get some info out of ESXi packet capture when we need a deeper look at what's happening at the host level. So there's a packet cap-UW that we can use to get information about the flow of traffic. So here's some of the key parameters in flags for packet cap-UW. We can identify the switch port. We can identify the direction, the stage, the flow filters, give it a certain output, and then give it a name. So switch port, we can see here when we run the netstats command, we see our switch port there as well. So switch port ID. With packet capture, so here's our ESX CLI. This is in the vSphere command line interface. We have the ability to do a VM port list -W. W would be for the world ID that you can see above there in red. So for Ubuntu-02 VM, which we can see is connected to one port, and we're looking at that particular port ID 50331692 as the port for that VM. And we can see the VM NIC name there, the VM NIC 1, as well as the uplink port ID. The direction defaults to 0, which would be switch input. We can also put a direction of 1, which would refer to the switch output. Or we could do a direction of 2, which would be in and out. So default of 0, we can use 1, or we can use 2 for the in-out. All right, let's look at some DFW troubleshooting. First out of the user interface for vDefend, so straight through our manager. If we look at our inventory, click on a virtual machine, we can see some important information here about this virtual machine. So we have the Horizon-CS01 virtual machine. It's the name of the virtual machine. And we can see its virtual interfaces there. So there's a network adapter 1 with an IP address. And we see something there called VIF attachments. You don't have to really look at the entire string, but if you just kind of recognize the 2F38576B, just that little bit of that beginning string there for the VIF attachments, you'll see here in a couple slides that that's going to come into play. But if you click on to dig deeper into the VM, you can see it's Windows Server 2016. What is the vCenter server? What host is it running on? So additional information there. Now, if we pop into the ports configuration, so again, it's the Horizon-CS01 VM. We have the ability to look at firewall rules. So if you want to use the user interface to determine what rules are being applied to a particular virtual machine, it's exactly what we're seeing here. And we can see our new rule there. We can see our default layer 3 rule is also applied to it. And then if we continue to dig down using a command line now. So now we're talking about using the NSX command line interface. So this would be run on the host where the virtual machine is sitting, so the ESXi host. And we've got some useful commands of get firewall VIFs. And there, if you look, we see a VIF count of 2, and maybe you recognize the 2F38576B. So I just pointed that out as being the VIF attachment for that Horizon CS01. We also then have our command line interface for the firewall to look at the rule set rules. So the firewall rules. So we see the VIF UUID there again, the 2F38576B. And we can see the same rules that we just saw in the graphical interface there. So rule 2059. And then we have our default rule you can see there at the bottom with the any allow rule. And then we've got our get firewall VIF UUID with the address sets. So as we've learned in a previous module, we have a lot of this great management capability inside of vDefend, but ultimately under the hood, we have to be able to translate into IP addresses so that we can understand how to communicate or how to prevent communication. So here we're able to really dive down and pull back the IP addresses that are relevant for these firewall rule sets. Another option, again, on the host where the virtual machine resides, using command line interface. Some useful commands, the summarize DV filter command. We've got the VS IP IOCTL command as well. So we can use the get rules with the -F and then whatever filter we want, or we can get the address sets, or we can get firewall config, which is what we see in the screenshot there. So running that against a particular NIC and then getting back the rules so we can see rule 1596, 1595, 1594. So we're able to see what rules are applying. Now, I just want to take a moment to review what we talked about before with regards to the applied to field, right? This is where we would see how efficient our rule applications have been, because if we're using the applied to, then the only rules that we should see here are the rules relevant to this VM, right? Anything with the DFW set as the applied to, as well as anything where it's been directly applied, to a particular security group that's been constructed. So ultimately, when you start to enumerate these lists of rules, you don't want to see extremely long lists of rules. If you're doing that, and you see an extremely long list, one of the first things you would want to check is, am I properly using the applied to field to make sure that my rules are working in an efficient manner? I'm not going to go through all of them, but we've got a handful of different commands that we can run off of the root of VS IPIOCTL. So we just saw a few with the get firewall config, but there's rules, address set, containers, flows, connection count, connections, stats, all kinds of things that you can run. So just a really good tool to be familiar with and understand the capabilities in case you need to get to a command line to test things out. And then let's finish up here and just talk about some common tools, not necessarily things that are specific to the vDefend product or VMware in general, but some common tools that you can use to help troubleshoot, starting off with netstat. So this is a command line network utility used to display network statistics and for troubleshooting network connections. It can show you active TCP connections. It can show you ports on which a computer is listening, as you can see in the two screenshots there, as well as other network information. But this netstat tool is a very valuable tool for network administrators or anyone needing to diagnose some kind of network issue. Next common tool we'll talk about is TCP dump. So TCP dump core use cases, things like network troubleshooting, security auditing, performance analysis, network monitoring, packet decoding, key functions, packet capture. So TCP dump will capture network packets, which obviously are the basic units of data transmitted across a network. It'll do packet analysis, so displaying the captured packets, providing details about the contents, the headers, and the timestamps. You can perform filtering, so you can filter packets based on various criteria like source or destination, IP addresses, ports, protocols, and more. You can save captures, which is really nice. You can save the captured packets to a file, usually in a PCAP format, for later analysis or review, or even take that PCAP into some other tool and run the PCAP in that tool to be able to display the data in a different way. TCP dump is great for troubleshooting because it's capturing and analyzing network traffic, so it helps identify network issues. It can help identify bottlenecks that are causing performance problems. And then finally, most relevant to what we've been talking about, of course, is security. So it can be used to detect malicious activity, port scanning, or denial of service attacks by analyzing the network traffic patterns. So quick screen capture here of our TCP dump, just looking at information for source, destination, the sequence. This is typically what it will look like. And the more you use this, the more you become familiar with the nomenclature, the result set. So we can see the client IP in light blue there, the server IP in green, the client port in a little darker blue, the server port in red, any flags, and then the sequence number of the packet. Last tool, Netcat. So Netcat is a very versatile command line tool that can be used for port scanning, so checking which ports on a remote host are open and listening for connections. Can actually do file transfer, so sending data, including files, between systems. Network communication, creating basic communication channels for sending and receiving data, which sometimes used for simple chat programs or debugging. Network testing, testing network connectivity and troubleshooting issues by creating connections and sending data. Security tools. So Netcat is often used by security professionals for various tasks, including penetration testing and vulnerability assessments. Maliciously or potentially malicious is backdoor access. So it can be used to establish a backdoor connection for unauthorized access to a system. Netcat can do data streaming, so sending data between 2 points on a network. It can identify the services running on a server by reading the banners, so banner grabbing, and then log data gathering, so collecting information from logs or other network sources. So obviously a tool that has a lot of capabilities in it as a network administration or a network engineer or security engineer. Having some fluid knowledge of these tools will allow you to troubleshoot things a little easier. All right, that wraps up our module on troubleshooting. Thank you.